very much. And good afternoon. Good afternoon, everyone. I hope you can hear me. On
Yes,
behalf of the Okay, thank you. On behalf of the AusIMM Tarkwa Student Chapter, it is my honor to introduce our distinguished guests for today's workshop, themed Navigating Operational Hurdles in Tailings Management, Implementation Challenges for Thickened Tailings, and Paste Backfill in Mining Operations. Our chairperson for the session is Dr. Clement Kweku from the Department of Mining Engineering, University of Mines and Technology, UMaT. And our guest speaker is Mr. Godwin Commey, Chief Executive Officer of Geocrest Company Limited. As a reminder, their full biographies have been shared on the WhatsApp group for your reference. Dr. Atta and Mr. Commey, you are warmly welcome among us. We look forward to an insightful and inspiring session. Thank you very much.
Okay, thank you to Arori. At this point, we'll have our chairperson, Dr. Clement. Please, we'll be honored to hear from you.
Okay. Thank you very much, Madam Moderator. I'm in the person of Dr. Clement Kweku as the chairperson, as I was rightly introduced. And this afternoon is a very great afternoon for us to come together to listen to our guest speaker on the topic navigating operational hurdles in tailings management, implementation challenges for thickened tailings and paste backfill in mine operation. I remember, I think the beginning of the year, I had the opportunity to sit in a meeting where we were talking about tailings dam. And in that meeting, we talked about the consequence of dam failures. When the tailings dam fail, some of the various consequences that people go through. So it's very important that we get to understand and really appreciate the management of a tailing pond or a tailings dam. Okay, so this webinar is a very good webinar for us to really appreciate the whole topic about tailings dam management. I remember Mr. Henry was saying that it's not really a mining topic per se, but it cuts across mining, geology. Why am I saying that? Rock mechanics, construction materials, just for them to really understand and appreciate all this. Okay, so please. So that when we leave UMaT, or we will get something, we can be equipped with something new. I know this topic is a new area altogether for some of our students. To be out of here. So thank you so much. You're all welcome to this webinar. Thank you.
Okay, thank you, Dr. Clement. Okay, so we are moving to the most important section of our workshop, that's the technical presentation. And we'll call on our guest speaker, Mr. Godwin Commey, to do this presentation for us. Please, sir, the floor is yours.
Thank you very much, and a good afternoon to you all. Thank you for the opportunity to share a bit of insight on tailings. It's interesting, the topic that you chose, because that's like the future of tailings management. So I'll see how I can touch on the operational hurdles and how it sits well with your career progression as well. I've been introduced already, but just by way of courtesy, my name is Godwin Commey. I'm a geological engineer, certified project management professional with 20 years of experience, and I'm the founder and CEO of Geocrest. We do a lot of tailings design and construction supervision and audits for most of our clients. We are actually a 100% Ghanaian owned company, but we also have offices and projects in other parts of West Africa. Yeah, so I look forward to an insightful presentation from you all, and I hope everybody gets something out of it. So I'll just take you through the overview. And usually when I present, I like to present in the form of asking questions, the why, the how, the what, so that we can all be able to really understand and appreciate what we are trying to pass along. Yeah. So the overview will be on 7 areas. First of all, the introduction, what is tailings management? We first need to understand what tailings is, how is it managed, and it's based on how it's managed that has brought about the transition into the thickened tailings and then the paste backfill. And then we'll look at what is the strategy behind the transition. And then we'll touch based on thickened tailings, the concept, the benefits. Thickened tailings are usually for surface operations, so that means open pit mining operations. Paste backfill usually apply a lot more to underground mining operations. So we'll also look at its concepts and then the benefits. Then we'll look at the operational hurdles with this concepts, and then we'll now discuss how we go about it. And in going about it, that is where I also touch on some of the skill set that will be required, so that at least you all will be informed as you come into the career world. What are some of the key skills that are required in effectively managing a tailings facility? And please, I believe you can all hear me clearly. I understand I have 30 minutes, so I'll do my best to finish within 30 minutes and open the floor for some questions. Yeah. So tailings itself, it comes from the word tail. So you have the head, you have the tail. So it's what comes out at the end of the processing of the ore. So tailings are waste materials left after extracting valuable minerals from ore in mining operations. So because you extract the ore, the rock or the soil particles, and you need to extract the ore, they are usually mixed up with various chemicals and reagents. And the tailings usually comes out in the form of a slurry, where there's a lot of water, and then the rest is the actual solid particles that you have in there. Yeah. So tailings management, I would say it's basically the process of storing, operating a facility, and then disposing of the tailings in a way that will not cause any harm to people and then the environment. So if you want to know whether you are effectively managing your tailings dam, you need to ask yourself a few questions that does it ensure the safe confinement of the tailings, which is this slurry material? Are you preventing any form of contamination of the soil, groundwater, and ecosystems? Because it's an impoundment. And most tailings dams are built with material, lateritic materials. You also need to ask yourself that are you reducing the effect of catastrophic failures? We've heard of recent dam failures. I think one of the gentlemen touched on that. I had a discussion with someone recently. So you also look at the environmental and safety standards, because if you are managing something, there are various rules and regulations that will guide you. So within the tailings management space, we have various protocols and standards. In Ghana, for instance, we have the MINCOM standards, the LI 2184, if I'm right. And then we have the CDA standard, the Canadian Dam Association. We also have ANCOLD, Australian system for large dams. And then we have the GISTM, which is the global standard for tailings management. So tailings management covers the entire life cycle of the facility, but then in managing it involves certain key aspects. And with this aspect, I also touch on some of the skills that will be required. So we look at characterization and planning. Like they said, if you fail to plan, you plan to fail. So where you even want to site or locate your tailings facility, its proximity to nearby settlements, they are very important. Just look at the geochemistry of the tailings itself. So you need people who are very good with waste rock characterization to come in and to help you and to advise you in the life cycle of the tailings. You also have the TSF design. This relies a lot on I'll say computer aided design CAD. So if you are trying your hands on AutoCAD and other softwares, I think that is the beginning of that before maybe you move into Slide and Wedge and Mark 3D and those other um, um, software packages that you need, because you need to make sure that the structural integrity of the facility is protected. You also need to be mindful of erosion, because this facility will be exposed to climatic conditions. So you need to make sure that whatever you're designing can hold the slurry material and can also withstand other environmental factors. Another thing to within the life cycle of the tailings management is water management. And please, if anyone has a question, I don't know who is moderating, if you might want to interrupt and ask your question. So I keep checking from time to time with your respect. Yeah. So yes, water management. This is where
Where? Lenda. Hey, huh.
hello. Yeah, so water management, you need the help of a hydrogeologist and then a hydrologist, because you need to understand the groundwater flow regimes. You need to also know the behavior of surface water and how they can influence the operation of your facility over time. Then look at the operation of the facility, the day-to-day monitoring and evaluation of the facility. This is, I'll say, is more of the future, where there's a lot of instrumentations that are monitoring the facility in real time. So they install vibrating wire piezometers, monitoring the pore pressures. You have inclinometers monitoring any lateral displacements within the environment, and some even link it to satellite imagery, so you can see what is happening in real time. So if you are quite good with GIS, you are quite good with some of these ground positioning systems, this is something that you can also consider. And then the last part of the life cycle is the closure and then the rehabilitation. So since we'll be talking more about taking tailings and paste backfill, we need to drain the water out of it, because tailings management is basically about wastewater management, if I may say, how you manage water. When it comes to closure and rehabilitation, for me, I'll say I prefer when the land is restored to its original form, not just to restore it to the initial topography, but to make sure that you reintroduce the original flora and fauna that were there before the mine even came. Because in the life cycle of a tailings or of a mining operation, the environmental teams put in a lot of effort in trying to preserve most of this natural or most of these indigenous plants and species. So it's very good if we are done with the tailings facility, you're able to restore it to its original landform. The picture below is just to give you an idea of a cross section of a general tailings facility. So you have the core impervious fill, and then you also have under drainage systems as well that are able to filter out any form of water. You have the riprap, which is basically waste rock that are usually put on the upstream section to control erosions. And freeboard is basically the space between the crest of the embankment and then the level of the decant water. There are various expressions for the freeboard. We have operational freeboard and we have water freeboard, and that's also another thing to also look at. And all these things have to be done in accordance to the standards and the technical specifications that I did mention earlier on, like the MAINCOM regulations and CD and all those other ones. Yeah. So now we'll move into the transition. So I've just gone through what a tailings dam is, how tailings dams are managed. Now I want to go into the transition, and then once we move from the transition, we'll now look at the thickened tailings and then the paste backfill. Then we can look at the operational challenges. So mining operations evolve, as human as we are, we ourselves, we are evolving over time. And we always, hello, there's a bit of background noise. Thank you. And we are evolving as a species, and there's a continuous improvement. So whatever you're doing, look at ways to improve upon it. Look at ways to make it better. And when it comes to tailings, there's a lot of how can we make it environmentally friendly, and also now there's a lot of focus on ESG, achieving certain goals and aligning to certain protocols and certain systems. The conventional tailings facility usually has high water content. Okay. And if I may say, this shift is not just technical, it is also strategic because it has to reflect our commitment to safer, more responsible, and more efficient mining practices. And I'll say one of the countries that have really taken the advanced tailings management method seriously is, I'll say, Chile and then Peru. Okay. And then so like I said, why the strategic transition? High water content in slurry tailings requiring large tailings down because you are holding a huge volume of water. So you need the space to confine it. And you ask yourself, how sustainable is it? How safe is this? There's also the high potential for dam failure, seepage, and water contamination. Water is quite powerful. If you confine it with time, it will try to look for ways to move because there'll be a lot of stress on the embankment walls trying to keep the slurry in place. It also requires an extensive land use. Most tailings dams, we usually talk about it in kilometers square or in hectares. So it tells you how large it can be. Some even trying to walk around the perimeter of the facility, you cannot finish, unless you are some athlete or something. There is also limited water recovery. So this is one other thing that is also informing the transition. Ideally, you are supposed to recover most of the water and reuse them in the processing of the gold. But when you have the water sitting in open ponds, there is evaporation, so you are going to lose the water. And we all know that water is becoming a scarce resource. We know of the galamsey challenges the country is having and the fears of sourcing clean and potable water in the near future. So mining in certain arid conditions, as you move, let's say in Ghana, as you move towards the Savannah, Sahel, and the Sahara, the weather there is hotter, it's drier, there are fewer natural water bodies for you to even draw this water from. So you need to look at innovative ways where you need the water, but you need less of it. And then also there's cost and liability. When you design such facilities, usually you need to even get insurance companies to insure your work for you, what we call professional indemnity insurance. So if it's a huge facility that is close to settlement, then insurance premiums are also high. So how do you also work on that? Now, looking at some of the benefits of advanced tailings management, it improves safety. That is number one, because on the mine side, safety is number one, and safety is everybody's responsibility. It also enhances sustainability through lowering water usage and smaller environmental footprint. There's also operational efficiency. There's better integration with underground mining and water circuits. And this operational efficiency is more to do, I'll say, with this particular write-up, with the paste backfill, because it focuses a lot on underground mining. But even with the surface operations, it can improve on your efficiency. In some parts of the world, they also call it responsible investing, where once the ore has been extracted and you have this leftover material, if it's non-acid forming, you can sell it to the construction people. It's like sea sand. It becomes like sea sand when you scoop sea sand with your hand and you squeeze the water out of it. What is left? Yeah. So now we'll look at taking tailings. And this is usually for surface tailings disposal. And it is what we usually call the stack. Once the material comes, I'll share the next slide. I'll share some picture with you on how a paste, like a thickened tailings facility looks like. So usually they extract the water out, and you usually work with certain specifications. So the target might be to not go beyond 18% or 20%. So let's reduce the water from the slurry from, let's say, 65% to 20%. And then once you're able to reduce the water, what you have left is what we call the stack. It's sometimes like, I would say, biscuits. When you extract the water out of it, comes in like thin sheets, and then you spread it over the surface, allow some bit of evaporation to also improve on the moisture for you, and then you spread subsequent materials on it. Some of the benefits for the thickened tailings are significant water loss. Also smaller footprint because you're not holding a lot of water. There's improved geotechnical stability. Water causes a lot of problems with tailings. There's also reduced risk of dam failures and leads to a more efficient and cost-effective mine closure process by creating a better landform because you would have released most of the water. So what you left with will just be the solid particles, which is easier to manage than when it's in a slurry form. Yeah. So the challenges with thickened tailings is that it requires specialized equipment. So if you build your conventional processing plant to treat or to extract the ore, you also need to have an adjoining plant that the sole job will be to extract water from the slurry, leaving out the stack. And also, it requires careful pipeline design to avoid blockages. So this is where, for some of you, you can also consider hydraulic engineering. So sometimes for us, we rely on hydraulic engineers who are able to work out the flow rates, the viscosity, where to put the bend, how to do the gradient of it to avoid maybe blockages and some challenges in operating a facility. So, like I did mention, this is an image of a thickened facility. So they usually add a flocculant. A flocculant will basically clamp smaller or finer particles together so that they can be easily transported. Otherwise, they will keep floating and it will be difficult for you to decant the water or to reuse the water, if I may say. Yeah. So now we'll touch on paste backfill. So thickened tailings has to do more with surface operations, and paste backfill has deals with underground operations. So with this, what you simply do is that with the conventional slurry that you have, that's the tailings, you mix it with cement or with other binding materials, and then you pump it back into the voids or the underground voids and fissures to provide some form of stability for the facility. So it supports the underground structures, it reduces surface disposal, it improves safety, it reduces the waste footprint. So if you notice, safety is very key in mining. So both of them, safety still comes in here. And one of the challenges is that it's high cost because yes, you need to buy all those chemicals. The logistics in moving them, to make sure that they get to the right places, a bit of vibrations here and there to make sure that the material sinks and sits where you want it to sit. And also you need to have some precise mix designs and ratios just to make sure that you achieve what you want to achieve. So this is just some image of a paste backfill. So after it goes through the various processes, if I may say, you have your cement silo, you have your water, and then you have the mill tailings. You mix it all together, and then this material now becomes what you pump into the stopes to sort of improve on the strength of the underground facility. So now we are going to move on to I don't know if I touched on, yes, we are going to move on to the operational hurdles, for paste backfill and then thickened tailings. So one of them is the rheology and pumping challenges. Okay, so each slide from here, I'll take some of the operational challenges and then we'll expand on it. And the one of the challenge with the rheology is that, before a dam is constructed, you go through detailed design phases and everything, and all these things are planned before the actual gold is mined. But what happens in the conceptual stage is really different from what happens on the ground on a day-to-day basis because the ore composition changes over time. Because you might be used to some weathering profiles whilst extracting this ore at this particular stope or this particular domain. You move and then the composition changes. So if you are working with the same ratios or the same estimations, you also need to be very versatile in paying attention to the various changes happening. Whatever material is coming to the process plant, you need to pay attention and you need to also adjust your chemical formulas so that you don't have any issues with pumping. And let's say somebody will ask, what is non-Newtonian flow? Okay, it's basically the movement of the fluid whose viscosity changes depending on the amount of stress or force applied to it. So we are talking about so as density increases, so does the need for high pumping pressures because you need more power to push the material through the pipeline, and which will increase your energy demands and equipment stress as well. We'll touch on equipment downtime as well. Yeah. And like I said, the ore composition varies. So you can get variable slurry quality over time. So you need to pay attention to that. Yeah. There's also the issue of blockages and wear because these pipeline systems, they are exposed to all sorts of weather conditions, though they are built to withstand them. Um, because they are being used over and over again, they are going to wear out, and most of these pipelines have valves at certain locations, they have spigot points at certain locations. So here again, you also need to rely on your hydraulic engineers to also help you. So you work with the processing department. So for you to properly manage this operational challenge, it's very important that the tailings engineer works closely with the metallurgical engineer or the processing team. It's very, very important because they will need to feed you the information. You also need to feed them the information to avoid some of these problems. Also, non-segregating paste must be maintained. You need to make sure that the viscosity of the material is maintained throughout so that you can easily move it out. But if it's varying over time, you can have challenges and the materials are not able to mix or to separate properly. Another operational hurdle is the operational reliability and control. So you have the thickener underflow control. And with this one, you need is the consistently achieving the target density. So with this one, we have what we call the control limit and then the specification limit. So you need to make sure that, okay, this is the specification limit, but to also maintain the quality delivery of whatever you are doing. You can also have certain internal control limits to make sure that you don't exceed so plus or minus whatever range you are dealing with. And there's what we call the risk of roping. With roping is when I'll say the materials clump together, they come together, and then they are concentrated at certain portions of the slurry transport, and sometimes it can happen when you have certain sharp bends or you are not achieving consistent density, target density, you can have some of these challenges. Yeah. And there's the flocculant dosage. And flocculants are basically chemicals that are added to clump the fine materials together into a larger mass. Then it's easier for them to be transported because if they are all extremely fine and light, then they will just keep circulating and they will not really settle. And one of the challenges is that if your flocculant dosage has to be precise, if there's too little, it may cause the solid not to settle properly. If it's too much, then there's wastage in the system. So which means that you'll be spending a lot more money buying flocculants to meet the criteria that you are looking for. And all of these things are equipment. Mines run 24/7, but some of these machines need to be serviced because you have pumping machines, you have motors that are running. They even need routine servicing. So sometimes that can also bring about some challenges because you also have your HSE demands that you also need to do. You have your maintenance schedule that you need to go by. So sometimes that can also be a bit of a challenge when you have to shut down for a while and do maintenance, but the people say one more go, so they keep processing, so sometimes it can be a bit of a challenge. Another operational hurdle has to do with geotechnical and deposition risk. So with a thickened tailing, you need to maintain some beach angle. I'll say a slope from the embankment towards the center of the impoundment. So sometimes that can be a challenge under varying weather conditions. It's raining today, it can affect it. It's extremely windy today, it can affect it. Okay. And then there's drainage and consolidation. We need to ensure rapid water release and consolidation for stack strength is crucial for long-term safety. So when it comes to the paste backfill, the binder lean zones, inconsistent binder distribution can lead to poor curing. And this is because you are dealing with cement. So you need to make sure that your mix ratios and everything are on point. And underground instability, weak zones compromise structural integrity and long-term underground support. Certain zones are weak in terms of whatever sharing or process that has happened down there, and you still need to release the paste backfill there. You have to make sure that your binder distribution is uniform, okay? Because binder lane areas will result in poor curing and shrinkage. And this can weaken the backfill structure, okay? And this directly will have an impact on your underground stability and pose serious risks to mining operations. Yeah. Economic and personnel constraints. So there is conventional tailings management, but you want to be innovative to introduce thickened tailings and paste backfill, which is an additional cost. So you need to also go through like some form of a financial investment decision where you need to put together, do your scoping studies, and need to make sure that it's feasible before you can go ahead. And with this one, whether you go ahead or not, there has to be some capital investments, okay, for people to come and do studies and give you technical report for you to make an informed decision. There's also high operation cost, okay, because if you are installing an additional facility, that will come with its own energy consumption. That will also then bring in the recurring costs for the binders, like the cement and the flocculants. And then there's the skills gap because already there is a shortage of tailings engineers in the industry. So if you also want to introduce innovative or modern ways of managing the tailings, then which means that you need more technical expertise to operate the facility for you. So that is another operational hurdle that we should also look at. So just to recap, we've touched on the rheology and pumping challenges. We've touched on operational reliability and control. We've touched on geotechnical and depositional risk. And then we've also touched on the economic and personal constraints. So now we'll delve into the navigation, how we can go about it. So we have real-time monitoring of density and viscosity using sensors and automated feedback loops. You also have all blending strategies to reduce slurry variability and stabilize particle size distribution, using additives to maintain non-segregating paste consistency, specialized pump selection. That's the pipe design optimization also comes in, short runs, wear resistant materials, and strategic placement of control valves. Because like I did say, the slurry will run through a series of pipes, huge pipes, between the process plant and then the TSF facility itself. And also thickening and paste preparation. Automated thickener control systems to maintain target density to prevent roping. Dynamic flocculant dosing systems with feedback from turbidity and settling rate sensors. So this is why I would say too much of a flocculant, you will not get a desired result. Too little, you will not get it. Too much of it also becomes a problem. So if you can be versatile or dynamic, then that will also help you to overcome some of the hurdles. And then preventive maintenance schedules for high pressure pumps. So you don't wait for a breakdown before you react. So some people sometimes have one or two spare parts or pumping systems or submersibles or whatever available. So whenever it's time for them to do any form of maintenance or something, they quickly go swap it, and then while they are working on the incumbent one, the new one can be, working to reduce the downtime. And then also stack management, with the thickened tailings, like I said, once you have the stack material, you need to come up with a way to properly spread it and allow it to also dry before you place the next layer on it. And you have to, this is where they also use drone surveys, because you quickly fly a drone over the area. It can pick all the information that you want. You can run some simulations with it and see, okay, Now, let me focus more on, let's say, the northeastern corner or the southwestern corner to spread the material there so I can achieve some gradient. And just so you have a bit of understanding, the stack management, they usually like to slope it gently to the center of the facility so that if there's any form of accumulation of water, because the stack is not 100% dry, you've only reduced the water from, let's say, 65% to, let's say, 20%. So there is still some amount of water, you know. And once you make sure that as you are stacking the material, you have a gentle slope towards the center, then we put the riser pipe in the center. So any form of accumulation of water or decanting left behind can still be drained out. Another way is continuous process optimization, you know, so using real-time data for density adjustments and also advanced technological integration. So if you go to, let's say, a mine site, or if you are privileged enough to get to the control room of a processing plant, you see they have all these screens monitoring, you know, a whole lot of stuff. You might not understand it, but then if you pay key attention, you know that they are monitoring the percentages or the composition of certain materials at every point in time. So the moment there is a change or there's a shortfall, there's a trigger system and then it gets resolved. You also have rigorous quality control, it's all part of it, specialized training for mine personnel. So as new equipment become available to properly monitor, you take advantage of that to make sure that you are optimizing your pumping and then your tailings management. So in conclusion, I'll say that advanced tailings management has evolved from a technical option to a strategic necessity. The transition from conventional slurry systems to thickened tailings and paste backfill brings tangible benefits. And you can see here we have safety again, improved environmental stewardship, and greater operational efficiency. Because like I did say, all what we are talking about has to do with wastewater management. So effective wastewater management is the key to all what we are saying. This evolution is not without its complexity. Challenges such as geology control, unpredictable flow behavior, geotechnical constraints, and equipment sensitivity demand more than technological upgrades. They call for skilled execution, responsive design, and vigilant real-time oversight. So like I did say, currently in the industry, we don't have enough tailings engineers to manage the conventional tailings facilities that we have. So you can imagine the upside from getting expertise with this thickened tailings and also paste backfill approach. And then by proactively addressing these challenges with continuous technical and operational excellence driven by data and specialized training, mining operations can not only mitigate long-term risks, but also strengthen their commitment to safety again, resilience, and environmental sustainability. So what I'll do is that I'll make this slide available in a PDF form so that most of you can go through it at your own leisure time. And if you have additional questions or you need further clarifications, I'm sure you can do a bit of digging or a bit of research yourself. So I'll say basically every option that you choose will come with its own inherent risk, but you need to be in a position to properly manage it because safety is paramount in the mine site. And all this has to do with effective wastewater management. So I know some people might have some questions. So I'd like to bring the presentation to a close here and then make room for questions. Thank you.
Okay. Thank you so much, Mr. Godwin. Please, if you have any question, kindly drop it in the chat box. It will be read out for it to be addressed. Please, we are waiting for your questions.
Madam Moderator, according to the program, there are a few things to happen before the questions, so please check. Before the questions, can you hear me?
Yes, please.
Before the questions, I'll give some remarks, and then I'll allow some industry people to also come in, and then we take the questions. I think that's how.
Okay, sir.
Yes, can you hear me?
Okay,
Yes,
sir,
please.
can you?
Okay.
Yes, please.
So the next workshop is on environment, and it's important that a lot of you attend because one of my earlier careers was a reclamation engineer with BH. And so that topic will reflect on real case scenarios. But today it's about tailings, and I want to acknowledge the presence of Dr. Clara Abuntore of UMaT, Mr. Eddie of Geocrest, and other industry professionals. Today we talk about tailings, and tailings has been one of the major headaches of companies' board of directors. Why is that? If you get a geological resource, mine planning, processing design wrong, in many instances, they can be fixed, and the worst case is financial loss. But if you get tailings design wrong, you'll be looking at devastating environmental damage, loss of life, and long-term contamination. Let me give you recent cases that have happened. In the Zambian Copper Belt, 2 concurrent tailings dam failures affected millions of people. It contaminated local rivers with highly acidic water and heavy metals such as iron, manganese, copper, and cobalt. Recently in Indonesia, 2 dam failures at the same industrial park killed 3 people and endangered the health of hundreds of people. Bolivia, the Laguna Conte tailings dam failed, left 2 people dead, destroyed 47 houses, and impacted 70% of the population of the downstream town. But just go back a little bit, just 2019, 272 people died in Brazil, what we call the Brumadinho tailings disaster, where a tailings dam owned by Vale, one of the international mining companies, collapsed, unleashing a torrent of mud to the town called Vale Kweku. And prior to this, I've been visiting this particular operation frequently. The devastation prosecutions, including the CEO and the German company that certified the design. Consequently to this, the Church of England, and you will ask why the Church of England, the Church of England and the Swedish Council of Ethics came together to monitor tailings. This Church of England and the Swedish group of investors who together manage about $25 trillion of asset under management, just mining assets. And so tailings became a very big issue for them. So they requested for information on tailings dams from the mining companies. And that review found 166 dams have had stability issues which have not been reported. Just recently at a board meeting in Canada, I spent 30 minutes trailing the CEO and his team on tailings design. This was a project that was going through expansion. And my colleague board members asked why I was concentrating so much on tailings. And I took them through the historical incidents that have happened, that we should ensure that we cover all the gaps. And to their surprise, after all these questions, I asked for an independent technical audit to also audit so that we close the gaps. Just recently, I led a team to Ghana to acquire the Kweku mine. And one of the biggest risks at that mine was the way the tailings had been constructed and managed. So tailings is becoming a big issue. In fact, just 2 years ago, I was a guest speaker at UMaT, their safety training. And UMaT, in collaboration with Goldfields, conducted a simulation exercise. So apart from the security services, the Army, police, fire service, Red Cross, who knew it was a simulation exercise, the town itself, close to the tailings dam around Goldfields, didn't know. But when I got there, it was shocking that despite all the alarm bells, everybody move, evacuate. Some people were just doing their banku and leisurely walking around and so on. So if this thing was real, it would have been a disaster. Hundreds of people would have died. And so the follow-up was to sensitize the people in the area. In fact, I advised UMaT to emulate that exercise in other areas across the mining sectors. So that highlights the importance of tailings. And I heard the speaker talking about various professions that help: hydrogeologists, metallurgists, HSC, and so on. In the past, civil engineers had been at the core of tailings designs. But now we are seeing mining engineers, geological engineers, geomatics engineers who are specializing in those technical aspects of the design to also come into the area. You had mentioned the shortage of tailings experts. So this is an opportunity for you to delve more into the topic. Because as you know, in Ghana, it's becoming very competitive in the job market. Everywhere is choked. So if you can find a niche where your expertise is required, not only in Ghana, but across the West African continent, then it makes yourself more competitive. So mark this, 15 to 20 years from now, some of you will be in leadership positions and you will be confronting these issues that we are talking about. Technology would have developed and maybe it wouldn't be as bad as we are seeing it. But tailings is becoming very, very critical. In fact, in a recent investor show in London, where a group of about 70 investors were looking at a mining project, the guy who presented the tailings actually pushed out a lot of the investors because he couldn't address some of the challenges that these are not even technical men. What is the impact of flood? Have you accounted for ESG, safety, community simulations, and so on? While he concentrated more on the parameters, the technical designs, he was struggling around these very important questions. And as a result, many investors walked away from that project. So I want to conclude by thanking the speaker, industry people who are here. If anybody wants to contribute after my small speech, and then we'll open the floor for questions. But I encourage you to also attend the next workshop, which will deal with real practical scenario on the success of reclamation. When a mine says we have reclaimed an area, how successful is it? Does it match the pre-mining scenario and so on? I'll conclude by, again, thanking all of you and the industry people who have joined us today. So we'll leave the floor for any professional who wants to give a comment, and then the moderator will come in to open the floor for questions. Thank you very much. If George Asongo is here, we want to hear from you, the AusIMM representative for Ghana. If he's not, Madam Moderator, you can take over for the questions.
Okay, thank you so much, Engineer Henry. So sorry for the oversight. So sorry for skipping. It was an oversight. Okay, so we have some interesting questions coming in. Jepta Bonzi wants to know, please, what methods are used to verify if the tailings are properly treated and if used will not cause environmental problems? Please, what methods are used to verify if the tailings are properly treated and if used will not cause environmental problems? Please, can anyone address this question for us? Any professional, I guess, speaker?
Yes, during the life cycle of the tailings dam and in managing the tailings, we collect samples periodically. So you actually take a sample of the tailings at various depths, and then you run various tests on it. And the values that you get over a period of time, you can plot and see if you are properly managing the facility or not, and what adjustments you should make over time. So that's how but we manage it by routinely sampling the materials and running tests on it. I hope that answers it.
Okay, thank you so much. We have another question here. How can a tailings storage facility be designed and constructed to meet environmental, social, and governance standards, ensuring minimal environmental impact, respect for local communities, and transparent governance, while also ensuring the safety and stability of the facility? How can a tailings storage facility be designed and constructed to meet environmental, social, and governance standards, ensuring minimal environmental impact, respect for local communities, and transparent governance, while also ensuring the safety and stability of the facility? Please, please, can we have any professional addressing this question for us?
So I'll just ship this in here. So with this, you need to go by the the internationally recognized standards and protocols. So in presenting, I did mention the MINCOM rules and regulations, LI 2184. When it comes to tailings from clause 263 to clause 273, it spells out all the various criteria that you should go by. And also, I did mention GISTM, the Global International Standard for Tailings Management, and it states various principles that you should go. So, in a way, if I may use the word, it's like your Bible or it's like your Quran that is guiding you on how you should go about the design, the operation, and the management of the tailings facilities. And for GISTM, for instance, the number one principle is to make sure that you protect human rights and the indigents. So before you think about designing a tailings dam or anything at all, the first focus is on the human rights of the people and then the environment in which you want to operate. Yeah. And if I may chip this in, I see one, Stephen Fosu, who also asked, please, if we can use the tailings materials for backfilling, then I want to ask if we can also use it for construction purposes. Yes, we can use it for construction purposes, but we need to be mindful of certain hazardous chemicals. So it's a bit tricky for gold operations because for gold operations, they use cyanide in treating it. And one of the interesting challenges with thickened tailings is that once you reduce the amount of water, the concentration of the cyanide will definitely go up because the more water, the more diluted it is, the less harmful it is. But it's relatively easy for non-gold mining operations. For example, let's say lithium, you get your spodumene or your concentrate. Whatever is left, you can easily sell it out to the construction people, but you need to be doing your test on it to be monitoring the material. I hope that answers Stephen Fosu's question. Madam, please.
Okay. Thank you, sir. We have an interesting question coming from Ernest. He wants to know, so for small-scale mining enterprises that often lack the capital to construct or maintain proper tailings dam, what would you recommend as practical and safe measures that they can adopt to ensure effective tailings management? So for small-scale mining enterprise that often lack the capital to construct or maintain proper tailings dam, what would you recommend as practical and safe measures they can adopt to ensure effective tailings management? Mr. Godwin.
Yes. Okay. With this, when you have your huge tailings dam, the conventional tailings dam that most of the big mines operate, to reuse the water, you decant the water from the old tailings dam into a return water dam. This is usually close to the processing plant. So this water, which is trying to be recycled, has to be treated. So if you are running a small scale mine, then which means that everything will be downsized. Okay, so what you need will basically be a smaller size facility, and then you optimize the use of the water. But you cannot do without having an impoundment to hold the water that is being treated. Yeah. I don't know if that answers the question. You still need to do the same thing, but on a smaller scale. Yeah.
Okay, thank you. We have another question here too. Someone wants to know which people are responsible for designing the tailings dam in their mine. Which people are responsible for constructing tailings dam in their mine?
Yeah, it's a collective effort. So first, as our patron said, you need the geomatic engineers. They will come in there with their survey equipment, their drones and everything, pick the information that you need from you, the topographical information that you need. You also need your hydrogeologist to come in there, look at the flow paths of the various water bodies nearby. You need your hydrologist, thereby observing the surface water runoffs, how they are behaving. You need your geochemist who will also come in there. So it's a very versatile team. So you need all these people in there to come together to design a tailings dam. It's not one person who will do it end to end. Because sometimes you need a geotechnical person to come and do geotechnical site investigations, do an assessment of the material, and then that person will pass it on to somebody else. So it's usually a teamwork of various expertise. Yeah.
Okay.
Let me add that. Sorry, moderator. Let me add to what the speaker said. What we tend to do is have one company that will assemble all those expertise, so that company becomes the sign off that certify the tailings dam. So recently, I was involved in the construction of a mine, and that's the process we took. So rather than going to hire geochemists, geomatics engineer, and so on, all of them come under the umbrella of one company, and that company manages it on behalf of the client. And so we will have our own personnel working alongside that company, which has all those expertise sitting with them. And then we'll also have a representative engineering company that will also monitor whatever they are doing, audit and ensure that the construction is according to design and so on. Mr. Commey, if I've missed something, you can correct me.
No, please, you're perfectly right. Yeah. So it's usually a teamwork, Like in football, you have a keeper, defender. Yeah. So we all come together to design and operate a TSF. Yeah.
Okay, thank you, Mr. Godwin. Okay, so Clifford came up with this question. So this question is, what considerations are made in terms of climate, hydrologic, and hydrogeologic conditions of an area before the TSF's life cycle begins? And he also wants to know the properties of tailings that influences the design of the dam. So with the first questions, he was asking what considerations are made in terms of climate, hydrologic, and hydrogeologic conditions of an area before the TSF life cycle begins, and what are the properties of a tailings that influences its design, eh, the design of the dam. Sorry.
Okay. So with the first part, you look at the rainfall pattern within that area. So most of the time, we can go as far back as 10 years ago to look at the rainfall pattern within that area to establish what we call worst case scenario. So let's say in the event where there's a heavy storm, one that happens, let's say one in every 100 years, how much water are we expecting to hold and what we have to do. And then one other thing too is that I did mention earlier on, you need to understand the groundwater flow regime, which areas are recharge points, which areas are discharge points, because the base of the tailings dam needs to be an impervious layer. Some use clay and then HDP lining. So when it comes to that, you look at rainfall pattern in certain areas as well. We also look at seismic effects. Either event where there's any seismic activity, how is that going to impact the facility? So you need to look at all those things. When it comes to the material, that is where we also work a lot with the metallurgists. So they will take certain samples of the proposed material that will be treated, the one that has the ore bearing, and then they will also run various tests on the material. And then the geotechnical team will also perform various soil and rock testing. Okay, and then they'll come up with various parameters for the rocks and the soil that we are dealing with. So all these players will share their information in the design of the TSF. I don't know if that answers the question.
Okay. Thank you. Please, there's another question here too. Someone wants to know the rate of implementation of thickened tailings and paste backfill as compared to the already existing traditional methods. What is the rate of implementation of thickened tailings and paste backfill as compared to the already existing traditional methods?
It's something new, and anything which is new, it takes time, especially if it comes with additional cost. Some people will say, okay, if it's not broken, don't fix it. So there are a lot of conventional tailings facility available, and they are extracting their gold, and our gold price is good. So it's for most of them, they will continue going by the conventional way, unless there's a regulatory push, especially in areas that have water scarcity. Okay, so the key driver has to do with cost. The cost in constructing it and then the cost in operating it. And don't forget that every mine has a life, and at the end of the life, we need to decommission. So that also comes with cost. So that is the key driver. Yeah. The cost of construction and then the energy consumption. Yeah.
Okay, thank you. So we have an interesting question from Al Hassan. He wants to ask, so how can reprocessing tailing contribute to resource recovery? How can reprocessing tailing contribute to resource recovery? Engineer Henry, can you please help us?
Yeah, that's an interesting question. In mining, we have what we call the cutoff grade. And so depending on the price, what will be deemed as tailings now may be recoverable sometime in the future. When I was in Obuasi, the gold price was $150 per ounce. And so you will realize that a lot of the tailings a lot of the material that went into the tailings that might be economical around this time and so on. So these things happen, and companies therefore try to safeguard their tailings in case there's the need to go back and recover some of the ounces. I know of an instance in South America. Some gold out of it because of the economics and so on. So it happens. Sometimes too, there is a lady doing Colorado School of Mines looking at a series of waste dams and tailings dams in the United States. And she's coming up with a technology that can actually recover some of the critical minerals from these waste dams and tailings and so on. So all these contribute to resource recovery, and it will depend on technology as time goes. So that's why you're in fantastic universities like KNUST, UMaT, UNE, and so on. You will learn the skills. What we will call tailings now might be recoverable during your time, depending on economics and technology.
Okay. Thank you, Engineer Henry. Please, Mr. Godwin, please, this question goes to you. Please, what's the fate of tailings dam at the closure of a mine? What's the fate of tailings dam at the closure of a mine?
Please, I don't understand the question. What is the, come again?
Fate of tailings dam at the closure of a mine. In other words, what happens to the tailings dam when we close the mine?
Okay, so when the mine is closed, every dam, every tailings dam, as part of the design, before the design is even approved, there's always a closure plan. So every tailings dam has a closure plan, and usually it's tied into the life of the mine. So what you would do is that over time you review, if I may say, your closure plan based on the operation of the mine and how things are progressing. Is the mine life being extended or is the same? So the fate at the end of the mine is that you need to reclaim the land. So I did mention that some people restore the land form. The environmental team will reintroduce the flora and fauna that were there before the mine even came. So this is usually part of operating a mine. So we don't wait for the mine to close before we think of the fate of the mine. It's usually something that happens during the life cycle of the mine. Yeah. So there are certain tailings dams that have been converted to golf courses, certain tailings dams that have been converted to fruit plantation, palm plantations, and all these things are usually planned in the beginning of the design of the tailings dam. I don't know if that answers the question.
Okay, thank you. Please, we have another question too. The person is asking, what challenges are typically faced when transporting thickened tailings through pipelines and how are these mitigated? What challenges are typically faced when transporting thickened tailings through pipelines and how are these mitigated? Mr. Godwin?
Yeah, so usually you can have blockages, and this happens when there are certain bends or certain sharp bends. And then also you can also have leakages at certain valve locations over a period of time. So one of the innovations is to install sensors, at certain locations of the pipeline, just as they also do for the gas and hydrocarbon industry. So you have those sensors in there and they're able to give you certain information, just as the roping effect as well. So you can tell by the information that the sensors are giving you in real time which areas are experiencing blockages. And then whilst you fix them, you also check with the processing team if their chemical composition and how they are running the slurry is all okay. Yeah. So one way to do that is technology, relying on sensors, and another tool is routine maintenance and making sure that the inclinations and stuff are maintained for the pipe. Yeah.
Okay. Thank you once again. There's another
I'm
question
not
too
okay
here.
with some of the answers. Let me know.
Yes, please. So there's another question here too. How is the underground room's pressure measured during backfilling? How is the underground room's pressure measured during backfilling? I don't know.
So with this, you it boils down detailed engineering design. Okay, and for underground, I'll say that you need to determine the required uniaxial compressive strength of the backfill. You need to understand the material properties that you are dealing with, and you need to be able to redistribute the stress properly. Allowing vertical and horizontal stress distributions to cancel each other out. But with regards to how you can how the underground rooms pressure is measured during backfilling. I don't know if that has answered it. It's a lot of reliance on the engineering design and then also the stress redistributions for the underground paste backfill. That is the best way to ensure underground structural integrity. Yeah.
Okay. Thank you so much. There's another question to hear from Sekina. Well, she wants to know, how is technology being used to improve tailings monitoring and management? How is technology being used to improve tailings monitoring and management?
Yeah, there's a lot. I think I've seen Abdullah Abdul Mumin mention use of drones. Yes, that is one. And then also I did mention we install certain sensors like vibrating wire piezometers, that measures pore pressures within the facility. We also have inclinometers that measure lateral displacements, within the embankment. So this equipment can be connected to a central hub and then they can collect the data for you in real time. And now we have what we call the INSAR, where satellite imagery is linked to your facility. So you can be anywhere in the world and you can rely on satellite images to see what is happening on your facility. And you can program these VWPs or these inclinometers to collect information, let's say every 12 hours or every 6 hours. So maybe when it's rainy season, you can change the frequency if you want to let's say every 6 hours, or you can maintain every 12 hours to collect data for you. So there's heavy reliance on satellite imagery, real-time satellite imagery, and also on monitoring instruments, what we call the Internet of Things. Yeah.
Okay. Thank you so much, Sir Godwin. Please, if there are no further questions, I believe we can proceed. If you are not satisfied with your question too, please, you can reach out on the main AusIMM mining platform. Okay, there's a question coming up here. There's a question coming up from Kobna. Said, after the closure of tailings dam, what kind of tests are done to ensure that the place can be used or converted to vegetable production, since chemicals such as cyanide was used in the extraction of gold, as you mentioned? After the closure of tailings dam, what kind of tests are done to ensure that the place can be used or converted to vegetable production, since chemicals used such as cyanide was used in the extraction of gold, as mentioned?
Okay, so when a facility is constructed, even when it's designed, we always include monitoring boreholes. And these monitoring boreholes are located around the perimeter of the facility. So in the life of the facility, we do periodic water quality testing. We drop a container in there, take some of the water, because this is basically the groundwater within the catchment area. So after the closure of a tailings dam, the kind of tests that are done are usually the same tests that are done from the design or conceptual phase to the closure phase. So it's basically water quality testing to ensure that the groundwater is still safe, and then any crops that are planted on it, people can consume it without any adverse health conditions. So water quality testing during and at the closure phase. Thank you.
Thank you so much, Godwin. Please, is there any other question? Can we please proceed?
If not, George Asongo is now here with us.
Okay.
He is the international representative of AusIMM in Ghana, and he just held a meeting with the head office. So he will give us some updates and then also a few comments before we go to the next one. George, over to you.
Okay, thank you.
Good day, everyone.
Good day, sir.
Thank you very much for this opportunity. And first and foremost, I want to thank Mr. Godwin for a fantastic presentation on tailings. I heard a lot. I said today, tailings is being not thrown as waste as it used to be in the early stages. Even some people go back to reclaim it and make gold out of it. Some also use it for paste filling and others, which is quite beneficial to most of the mines today to serve as support, which also makes the mine more safer and makes the rock more stable. Mr. Godwin, thank you very much for this wonderful presentation. Just to let everybody know the purpose of AusIMM, and as students, I will advise that you don't belong to the wrong group, but this is a group that is out to shape you in your career, as you all know. And as professionals as well, also expanding our knowledge base, because day in and day in, we are learning. And for the students, you need to take this very serious. I've always been saying it. As I always indicate, if you go to the field, don't glue yourself to just the computer, but try to get to the field so that you can understand the practicality of what is really happening, so that when you come back and sit behind a computer and you are inputting anything, you have a better understanding of what you expect of the outcome. So you need to take these sessions very serious as much as you can, so that when you are going out, this is a great platform that is preparing you to come and join a professional world, and you have a better understanding of what is going on. I always say that you will have a greater advantage. We never had these opportunities. We were there with the books, came out just as, but you people are very lucky. You have mentors who are shaping you in your careers, academics, professionally, and some of you are even benefiting to understand what tailings is and the purpose of it and what it serves. Some people some years back completed And some of your colleagues, as at now, might have not even heard of what tailings does and what it means. But you are lucky. This platform is giving you a greater service that you need to hold onto it strongly and make sure you grab all the benefits so that when you go out to the industry and the language is being spoken, you'll be able to understand exactly what is meant. Because when you go to the industry, there are some words or terminologies that you have never heard before, and you may not find them in any books. But going through all these, and with the type of questions you are asking, you get to get a better understanding. So when you go somewhere and they are talking about paste fill, you understand what it is all about. They are talking about tailings, you understand what it is all about. In Ghana, the first mine to start using paste to backfill stoves was Wasa Golden Star, followed by Ashanti Goldfish Obuasi. You can imagine, it's not even up to 5 years. So you can see there's a new thing in Ghana, but elsewhere it was being used. But if you are not told, you don't have opportunity to be on platforms like this, that you get lectures on it, you wouldn't even know what the whole thing is about. So as I always say, take this opportunity and make sure you always avail yourself for these type of platforms and ask questions as much as possible. No question is wrong. Any question that comes to mind, try and ask, because it will not benefit you alone. Don't keep it to yourself. There's always never a wrong question. So when you ask, somebody also benefit from it. So I will encourage you to encourage your other colleagues, members and non-members, to be joining this webinar series that is ongoing. I once again say, don't let yourself out. Never let yourself out. And encourage your other colleagues to join you so that you can all benefit. And this will bring your growth to the highest. Once again, I want to thank the founder and everybody on the platform. And I also encourage the professionals to continue to contribute to support the growth of our younger ones, because you are the future leaders. You are the ones to take over from us. So we are also grateful that you've allowed yourself for us to groom you and bring you up so that you can gain all the knowledge that is required for you to stand to become outstanding individuals in the industry in future. Thank you very much. And I thank everybody. Thank you.
Thank you so much, Mr. Sunko, for the beautiful remarks. Thank you very, very much. Okay, so we'll proceed to the next thing. Please, we'll call on our chairperson to give us the closing remarks before we leave. Dr. Clement, can you please give us a closing remark?
Okay. Can I be here, please?
Yes, please.
Okay. Thank you very much. Okay, so thank you very much, Mr. Godwin, Commey, and I want to thank all of us for joining this webinar, which sought to address or to talk about navigating operational hurdles in tailings management, implementation challenges for Thickened tailings and paste backfill mine operation. We can all attest that it's been a pleasure for us to join this webinar because you've learned a lot. Mr. Godwin helped us to understand the difference between the thickened tailings and the paste backfill. We've also been enlightened on the life cycle of the tailings management. We also saw various tailings management hurdles and how to navigate around them or how to control them. I would say that this webinar has indeed been very insightful, and it has helped us to it has helped our professional, it is helping our professional growth. What I would say is that most students as mining engineering students are being introduced to courses like, let's say, rock mechanics, soil mechanics. But if you look at some of them, when you go for meetings, you realize most students don't really take it serious. So I want to use this opportunity also to encourage students to really take such courses very seriously, because they help in the whole, to build you up, because you don't know where exactly you'll be working one day. Because as you've already talked about training management, it's an aspect of rock mechanics. With aspect of rock mechanics, you saw different aspects, rock mechanics, geotechnical engineering. So let's take the opportunity to really learn something. Learn something from what you are learning in school. Some people always want the opportunity to go and work in the mines. And some students are given the opportunity to go and work or to do attachments in the rock mechanics lab at the university, and they were not happy. And I was telling them that it's a great opportunity for them to learn. So please, let's all, whatever opportunity comes our way to learn something, let's embrace it. So thank you so much for being with us for this webinar. And we look forward to seeing you on our next webinar. Have a great day. Thank you.
Thank you so much, Dr. Clement. Also, soon we have come to the end of today's workshop session. To finalize everything, we'll have a vote of thanks from Osafo Erica from Poma. Osafo Erica, please, over
Yes,
to
please.
you.
Okay, please. Okay. Good day to our distinguished guests, facilitators, and fellow participants. I'm very honored to be called upon to give the vote of thanks. I would like to thank the Almighty God for giving us this privilege to meet together as a family for this workshop to learn a lot on tailings management. I would also like to thank the organizers of this workshop for coming up with such an insightful program on tailings management. They have actually helped us to gain more knowledge about this important subject. I would next thank our resource person, Mr. Godwin Commey, as well as our industry men and professionals around for their time, dedication, and expertise on this important subject. We have actually acquired a lot of knowledge on this subject, and I believe it will go a long way to help us promote safer, sustainable mining practices in the next future and now. Lastly, I thank all attendees for this workshop. Your contributions and your active participation is duly noticed. Thank you all.
Thank you. That's a beautiful one, Erica. Okay, so far so good. We have come to the end of today's workshop. For me, I've learned a lot, and I know we've learned a lot too. Thank you all for joining. And please, we'll really appreciate your feedback on today's workshop. If you have any other question, or maybe your question was not answered the way you want to, please reach out on the main AusIMM mining platform. And please also share your insights. We want to hear your feedback on how things went today. Thank you so much for joining today's workshop. Please have a great week.
Thank you too.
Thank you.
Thank you all.
Thank you very much.
Thank you too. God bless you. Have a nice day.
Same
to you. Are you cool?
Yeah.